Hi there, localization people. Another long video now about the challenges you may face when using large language models or LLMs for translation. While there are many useful GenAI applications in localization, let's focus on translation for now because it's easier to understand new technology by comparing it to the old technology doing the same thing. So I want to tell you about some of your hopes which may not come true, or at least about some challenges you'll face down the road. And in short, LLMs are still very slow. Most of their power can be lost in integration with legacy software systems. Their full text capabilities may not be what you expect for translation, and both training and evaluating those models are much harder than for machine translation. First and foremost, LLMs are incredibly slow. We're talking about 100 times to 1000 times slower than traditional machine translation models. Even with GPT-4 fresh off the press being twice faster than others, it's still 50 times slower, meaning you cannot really use it for real-time translation use cases such as live chat translation or on-the-fly translation. Moreover, even if you use it from your translation management system, the synchronous TMS connection may not be able to handle such long wait times. Let's talk more about those legacy systems. The translation quality of LLMs is largely related to their full text processing capabilities. Now, when you use it from TMS or a CAT tool, they operate on segments or translation units, which means this large language model trained for millions of dollars on all data in the world is looking at your project through its tiny keyhole of a single segment, which is often just a sentence fragment. Which means, for that reason, to truly harness LLM capabilities, you may need some kind of external tooling or a middleware, such as our language hub. Now, some of you may be thinking, well, if it can translate full text, can I just send whole project in one go? Well, technically you can, and some of the models support as much as 2 million tokens or 1 million English words as inputs. But there are two catches. So first, output requirements are much more stringent. And for example, for this model with 1 million words, it's only 4,000 words as output. And since you're doing translation, effectively it means you can translate around 4,000 words. Second catch is that these large context windows were designed to handle long chats. So LLM puts lots of attention to the beginning, even more attention to the end of this text, and not so much attention to the middle. So if you translate the whole project in one go, then you may expect some omissions and deviations for this middle part. We recommend to apply LLMs at kind of paragraph level. When choosing an LLM for translation, you may see lots of public benchmarks and also information about number of parameters. Don't use those to choose the model, right? First, because those public benchmarks often included in the training data, so it's not kind of fair comparison. Second, they comprise of many tasks, with translation not being the most important. Enclosed translation datasets often paint a very different picture on who's the best. And for example, open source models actually have very weak multilingual capabilities compared to commercial models, which is not visible from public benchmarks. Another tricky topic we need to discuss is prompt management. You cannot simply transfer a prompt between different large language models. Something that works well on GPT may not work so well on Claude and vice versa. Moreover, you likely find that you need to use different prompts for different languages. And what makes this issue even more acute is that this kind of rapid evolution and deprecation of LLMs, meaning that at some point you may need to be able to quickly migrate all your prompts into a new model. Which means managing the prompts effectively will require a solution that goes well beyond a simple spreadsheet, right? And finally, let's discuss customization. So while you can use prompts, fine-tuning the model in translation memory is often the best approach. And as you know, to train machine translation model, you just upload your data, you press a button, and the model gets trained with bad segments, bad translations automatically filtered out. Because the training thing kind of knows what your goal is. And cost of this training will be capped around $300. Now, when you fine-tune an LLM, first you need to format the data. And that's some engineering right off the bat. Then you need to thoroughly clean the data yourself, because the model can be trained to do anything. It doesn't know what you're going to do. Maybe you want to train it to generate real-life translation memory with misalignment and inconsistencies. Then, unlike for machine translation, here you actually choose for how long you can train the model, so costs may add up very quickly as you pay for each training epoch separately. Therefore, creating small representative data sets is absolutely crucial. If you do it right, then you can get very substantial quality boost for about $500 of compute. So, in summary for today, LLMs today are mostly suited for non-real-time translation tasks, and they require special skills and tools to work effectively with legacy systems and legacy workflows. Well, that's kind of why we built our language hub, to help you make AI work seamlessly with your existing stuff. So keep these things in mind while you explore this new landscape, and well, stay tuned for more updates on how we are working hard to make LLMs more accessible and efficient.